You're the boss tonight, Savash, so I will do as you ask.
Yeah, thank you. I'll just get the quick introduction out of the way. As always, these meetings are recorded, uh, and most of you have already submitted the report. We're just gonna run the run the MOOC for another week, so we can put the marks in. So for those of you who had requested extensions, just keep that in mind because after the date finishes, we can put in your marks within the edX. So keep an eye on that end date that's on your WebEx page, the edX page. And with that, David has prepared a quick presentation and an introduction to spatial sciences. And I'll leave that into your capable hands.
All right, I'll just get rolling here. So, all right, we're all ready to go, I think. So, just checking that my microphone volume's all right. Can you hear me okay?
Yes, it's all good, coming through.
Fantastic. Okay, so just going to be a real brief introduction into spatial sciences, and spatial sciences really being about location is the simplest way to describe it. So I could go into all kinds of other things, but that's probably the easiest way to describe it. So to start with, we'll talk about what spatial is not. And the reason I usually talk about what spatial is not is because whenever I ask, or people ask me, what do you do? And I say I work in spatial sciences, they immediately think of NASA and am I involved in what now is Australia has committed $150 million to going to Mars, and people want to know, am I involved in that? I can tell them that that's probably where my kids would like me to go sometimes, but no, so it's not this space with a C, it's space with a T, and it's not spatial or spatulas, but spatial sciences. So the other thing is many only think of spatial sciences in the context of these kinds of things that we see in front of us, maps. Now, these certainly contribute to spatial, but it is a lot more than that. And this map here on the right-hand side that you see is the London Underground map. And apparently, apparently it is the most used map in the history of the world. Not quite sure where they have the data sets from the ancient world to know if there were other maps used this frequently, but that's what it's considered. But spatial involves a whole lot more around things like GNSS. Now, GNSS is always an interesting one because most people, when they think of GNSS, don't actually think of GNSS. They've never really heard of GNSS. We think of GPS, but GPS is actually one form of GNSS. And you're going, so David, what's GNSS? It's just Global Navigation Satellite Systems. And GPS, as we often refer to it as, is just one particular type of GNSS. So why is it important, spatial? Well, the more accurate we know about where objects are, the more detailed we can do things. And what do I mean by that? The more detailed automation we can introduce, the more we get a better understanding as to what relates to what. And as I had back on that first slide, everything happens somewhere. And I have that on our next slide here. And we sort of go, well, that's obvious. Of course, everything happens somewhere. So what? But it's more recently that we've started to really pay attention to where things are happening. And there's huge discussions about things like Facebook and Twitter, Instagram, and a whole bunch of the other social media networks that are tracking location. So everything happens somewhere, and we're now doing a lot more analysis on this kind of thing. And really, in a lot of part, it's come into the mainstream because of things such as Google Maps and Apple Maps. But spatial, it's a whole type of thinking, really. So it's a concept, or it's this concept of space that makes spatial a distinctive type of thinking. By understanding the meanings of space, what we can do is we can start to use the properties of it. For example, things like dimensionality, continuity, proximity, separation. These are all ways that we can go about structuring problems. And sometimes the better we structure a problem, the better the solution we can find to it. And not only that, spatial gives us an excellent way to actually express and communicate the solutions that we've found. So, and often they're expressed in the forms of maps and all kinds of variations of maps. You'll find people often perceive and remember information when it's presented well and presented in a map format. So when we think spatially, we need to think about space and what are some of the relationships among units of measurements. Are we using kilometers or miles? When we think of different ways of calculating distance. So here in Australia, what we often talk about when someone says, oh, how far is it? I would always say, oh, my friend Richard lives 30 minutes from my house. Now, my wife and I have been married for a long time, but my wife is German. So when we moved to Australia, she would often ask me, well, how far is it? And I'd say, oh, it's 30 minutes. For a German, that really was unhelpful. She wanted to know, is it 20 kilometers, 25 kilometers, 100 kilometers? That was when she asked for distance. That's what she meant. In my mindset and in a lot of Australian mindsets, if someone asks how far is it, it's 6 hours drive, it's 7 hours drive. So that becomes really important when we're thinking spatially and understanding differences between people and their way of thinking. We have to think of coordinate systems. There's Cartesian coordinates, there's polar coordinates, grid coordinates of specific areas. And then we also have a whole bunch of things in the area of dimensions. Are we talking about two-dimensional, three-dimensional, partial three-dimensional spaces? And then we even start to have a look at things like how is our space and what's the representation of it? What are the relationships among the different views? There might be a plan view, there's elevations of buildings, orthogonal versus perspective, Mercator. There's a whole different range of projections. And then even tying into spatial thinking is graphic design in the area of what do different things and different graphical designs represent and what does it mean. Now, a good example of a mix-up of graphic design in the area of spatial was when Apple Maps was first released, and a whole lot of things in the area where I live, the water spaces were represented with white. Now, most of us, when we think of water, we think of blue, but going back in a particular type of mapping format, water was represented in white. So the guys who were at Apple Maps hadn't actually taken that into consideration, that they were using, yes, it was a correct representation of water, but it was one that's just not used anymore. And it caused a whole bunch of problems in people understanding. There was a lot of mockery about things. So it was really quite a mismatch of things that were going on. When we start to reason about things in a spatial manner, we think of different ways about thinking, what's the shortest distance between one place and the next place? And there's, again, you can go back into, is the shortest distance kilometers or time? Now, when I go looking for things or for a location using, for instance, Google Maps, the first thing I'm told is a particular thing might be 13 kilometers from my house. Then when I hit directions, all of a sudden it extended another 9 kilometers and it's 22 kilometers, because the first way it was talking about the shortest distance as the crow flies, we say here, which is drawing a straight line. But as you would know, you don't usually get from one place to the next with a straight line. And if you do, you'll often end up in trouble with the police because you've gone through people's houses and through their backyards, and then you're usually considered something else rather than just a traveller. How do we extrapolate? How do we interpolate? How do we make decisions in spatial contexts? These are all things I want to be looking at. So I want to talk about Jon Snow. Now, I have to confess here at this point in time, one, not this Jon Snow, and two, I don't watch Game of Thrones, so I don't really know anything about this Jon Snow anyway. So the Jon Snow I want to talk about is this one. So he's considered an absolute revolutionary spatial thinker. And you're going, David, I've never heard of Jon Snow. I have no idea who he is, so why are we talking about him? Well, Jon Snow, back in the 1850s, lived in London, and at that time there were a lot of people dying from cholera. Now, cholera is a waterborne bacteria that kills people when you're not treated for it. And in those days, it was absolutely deadly. And what he started to do was he started to go, well, we have these communal taps or faucets, and being a waterborne bacteria, what can we do in regards to trying to find out what's happening? And basically what you see here is the map that he actually, it's not the map he actually made, it's obviously a digital representation of it. And also on the right hand side, another one, which I'll talk about in a moment. And what he did was he plotted where the taps were and where the deaths were, and started to look at, is there a relationship between different taps and death? What was important? Well, London was supplied water by two different water companies. One got the water from the aquifers of the surrounding farmland, and the other one got the water from the Thames River. Now, if you've been to London lately, I wouldn't recommend drinking water from the Thames now, but back over 100 years ago, it was the dumping ground of everything for London, and that was actually the drinking water. But it wasn't possible to know, or they couldn't tell you, which taps were supplied by which companies. So what Jon Snow did was he looked at the different taps and what were the death rates surrounding the taps, and looking at the number of users. So he was able to work out a death rate of some taps of about 5 per 1,000, and some other taps up to 71 deaths per 1,000 people of using the water. So what he was doing was he started to build an inference model where they could now infer which taps were being supplied by which water companies, and then from doing that they were able to close those taps down. And this map here is actually the map that they used in starting to isolate, and the darker colours are where there was some overlap and there was the different companies supplying the different parts of London with water. So what was he doing? Well, in that realm of spatial thinking, he was looking at things and starting to build relationships amongst the objects. And in this case, the objects were death and water. Started to do some analytical deductions and started to go, okay, what's the problem, and how do we structure it? and then took into this level of inferring, and he was looking at inferring which taps were supplied by which, and started to be able to answer questions. Now, what we now bringing all that back into, and you're going, David, what does this tie into my IoT thing? And that was a really high level understanding of things, but we're going to take that down into our environments in a really minute way with our IoT devices if we're using location. And we need to think things through. And I say, what do you want to do? So with our devices and with your devices, what do you want to do? And what do you want to do with location information from it? Then I say, when do you want to do that? And what do I mean in asking that question? Well, when are you wanting to actually be dealing with the location information? Do you want to deal with it instantaneously? Do you want to gather it? Do you want to deal with it later? When does it become important? What resources do we have? Well, we have to think our IoT devices often don't have endless lives of battery supply, of power supply. There's limited processing power. So we need to think, what are our resources that are available on our devices? Are we going to start to think of processing it on the device? Are we going to process off the device? Are we going to start to do some fog computing where we're using a combination of on-device and cloud? And in that sense, how are we going to go about actually doing it? So these are the things we need to be taking into consideration around our devices, because we have limited resources. And I know you're going to say, well, David, the phone I've got has more power in it than what we use to send man to the moon. And that's absolutely correct. The thing is, we're now doing a lot more with our phones or our devices than we used to. So we're using that kind of power. And you'll know if you use GPS systems, GNSS systems on your phones for extended periods of time, you do suck the resource of the power. So we have to think through those kinds of things. So that leads us into, so what would we do with it, David, if we're collecting information, location information? How do we start to process it? So we've got some options. Now we have a couple of major pieces of software. One is called, or the company is Esri, and they produce all of this proprietary software, which is extremely powerful, really, really useful, but it can also be expensive. There's QGIS or QGIS, which is an open source software system. Again, very powerful, no cost, it's freely available. But we come to that idea of where we start to make trade-offs. We have Esri, which is proprietary and comes with full support. We have QGIS, which has low cost, virtually nothing, but you're then working with a community support group. So what are your things that you want to trade when it comes to that? So there's more possibilities. They're not the only two solutions, and there's extensive amounts of spatial software and spatial processing software that's becoming available. There's specific spatial database systems. They generally run out of a normal, in a type of database management system with extensions to be doing spatial processing. And spatial processing is always an interesting type of processing because of the way we have to process queries. So PostGIS, which is an extension to PostgreSQL, is one of the really quite powerful spatial database systems. Sorry. Why would we want to use it? Well, a spatial database system has all of the benefits of a normal relational database system, but on top of that, it also allows us to do spatial queries. And you're going, what's a spatial query? Well, a non-spatial query could be something along the lines that I've got here. List the names of all bookstores with more than 10,000 titles, or list the names of the top 10 customers in terms of sales in the year 2005. Fairly straightforward query. When we extend it to a spatial query, we might say something like this: list the names of all bookstores within 10 kilometres of the city of South Perth, or list all the customers who live in the Perth metropolitan area. Now that takes on a whole different algorithmic calculation to answer that query. And this is where spatial databases become really helpful, because they're built to do those kinds of queries. PostGIS, just an open source library, some things we can go through. The most important thing here I want to talk about is this here, OGC. It implements the OGC simple fit, and you're going, OGC, what is it? OGC is the Open Geospatial Consortium, and it's an international consortium that has been running for a long time now, that's responsible for creating geospatial standards for technology, for implementations. And they do a lot in the area of web standards for geospatial data and geospatial processing. And they work really closely with the W3C, the World Wide Web Consortium, who are the consortium that are responsible for all of the web standards. So they work very closely in order for the W3C standards and the OGC standards to be compatible and working together. PostGIS is useful for all of these kinds of things, but we have to be thinking, again, where are we going to be storing the data? How are we transferring the data? This is where it becomes really, we need to start to think through our devices. This is just a dump from the Postgres SQL statement, giving us a few things. So I want to move on to one of the other types of, or other formats, where a lot of spatial information is now being stored. And this is in the JSON format. We've got a very simple format here that, if you're familiar with any programming language, we've pretty much got a key value format. In Python, we would call it a dictionary. The key being the name and the value being, in this case, David McMeekin. We then have another key, teaching partner, and you'll notice the open and the closing of brackets, curly brackets, and we're embedding information. So we're starting to nest information. And in the terms of a web environment, JSON is one of the very stock standard ways of transferring data around the web and across different across the HTTP protocol. HTTP protocol. We then go into GeoJSON. Now GeoJSON is JSON that just has geographic geometries stored in it. What do I mean by that? Points, line strings, polygons, multi-polygons, multi-line strings, and multi-polygons. Now GeoJSON and JSON are exactly the same formats. And now something to really keep in mind, because when you start building your data and creating your data sets and then combining them with other data sets, JSON and GeoJSON data sets are really common data sets. And people can think, oh, do they have a GeoJSON version of this JSON file? They're exactly the same. GeoJSON is just JSON with geometrical things in it. But you can use either the GeoJSON or the JSON file extension. It doesn't matter. Now, JSON/GeoJSON, like I said, are really common file formats. And if you go to a lot of the open data portals, you'll find that it's a standard way that you can download data sets with. For instance, if you go to the New York City open data portal, huge numbers of their data sets are available in the JSON format. In Australia here, data.gov.au supplies huge numbers of their data sets in a JSON format. So it's a really standardized format. If we start to process it in the areas of Python, what makes it really nice is there's a Python library that allows you to take a whole GeoJSON file and convert it in one line of code into a Python dictionary. And then you have the power of Python to start processing it. So this is just a straightforward GeoJSON entry, and you can see there's points, there's coordinates, and there's properties. Now, what you see there is just now visualized on a map. So, and this geojson.io is a great way that you can just visualize your JSON file formats when they're obviously got geometrical values in it. So this is the one we've seen, the coordinates, and that takes us here, which is actually the Spatial Sciences building on Curtin University. And over here you can see this one here, 314. So this is the building I sit in. This is the building that Ian and Savash and Hannes and Valerie sit in. So some more information about GeoJSON, some samples, and again, some more sample visualizations. So it's a really straightforward format. It's lightweight in the sense that it's just a text file. These are some things: geometry collections, features, feature collections. But it's a simple text-based format. It can be lightweight. Well, it is lightweight. It just depends how big the amount or how much data you're going to be storing in it. Very simple to move it around, to transfer it across the web. And it's extremely easy to parse and start extracting information out of it. So JSON, I've said most of those things. It's a dictionary. It can look like a dictionary. It's easily converted into a dictionary. And here is just some basic Python code to process dictionaries, which will be available if you want to use it. I just wanted to give that some example about that. Where this becomes really interesting, I think, is in some of the libraries that we can use to process it. And we have the Pandas library, which provides some really powerful data science and analytical tools within Python. And it provides us things, I say like this, there's the data frame, and we've got indexes, columns, data, really super powerful. And on top of that is the GeoPandas library. And that gives you all the power of the Pandas library for data analytics and data science, with a geospatial analysis possibility as well. So it becomes really, and you're going to go, stop with the reallys, but it is really powerful and allows you to do some fantastic analysis on your spatial information as you're combining it with other data sets. So tying it still back into your project, you have to think, why do you need location? Okay. Do you need location is another thing that we need to think through. Just because we can collect it doesn't necessarily mean we need it. So it's important that we think through, why do we need it? How much do we need? What do I mean by that? Well, do I need just one point? Do I need 1 point per day? Do I need 1 point per second? These are the kinds of things we need to think through. How much do we need? Where are we going to process the data? On device, on our IoT device, or are we going to take it off that and process it elsewhere? Where do we want to visualize it? Is it important that it's visualized on our device? Does our device have a screen that we're going to visualize data on it? Or are we going to, again, bring it off device and visualize it on a web page or within a separate application? And when we've thought through that, we have to think, what can I live with? What is enough? And these are things that are really important to think through, because otherwise you'll find you'll get to a point as you're developing your devices and go, oh, it would have been great to have that. Or as people, customers start complaining, well, we're running, the battery is dying way too fast. Are we actually collecting too much information that we don't need and we're not going to process? So just a little bit of food for thought in regards to some spatial sciences.
Thank you, David. So if anyone has any questions, feel free to use that raise a hand button right next to your name. I'll unmute you and can you ask your question? You can also use the text box at the bottom to ask your question if you're shy and wanna just type your question out. And we have I'm here, David's here, and we have Hannes. So if you have any questions, probably not about your projects, because hopefully by now you've submitted your report, but possibly about where you're gonna take your report in the future and possibility of maybe expanding your idea.
If no one else has something, I came across something fairly interesting to do with spatial sciences. David, have you come across the website What 3 Words?
What 3 words? I certainly have. I have zebra coffee snow is on my office door, for that is where I live. So
Very good. I thought that was a very interesting take on the whole location-based thing.
it's
For those
brilliant.
who haven't seen it, essentially it lets you, for any location on the world, generate 3 unique words to capture that location. So you can type in a location and get 3 words. So our building, for example, would be create, crisp, refuse. Or you can just type in 3 words and see where that gets you. Most of the good words seem to land you up in Canada for some reason.
That's because I think you'll find the guys who started it are Canadian. So but it is it's a great website, and it's been you'll find a lot of people use it, particularly at sporting venues or at big concerts. It's where it's very commonly used, because you're trying to find where someone is, so they will actually give the 3 words, and there's an app you can have on your phone, and you pop in those 3 words, and it gives you a very accurate location. Let's see, Sebastian's brought up the web page. I can't remember exactly what it is, if it's 3 square meters or something. So it's really really helpful for those kinds of events.
Interesting.
It's also, just talking about it, a great conversation starter, because I have on my door, my office door, zebra coffee snow. It's usually people go, "What on earth is that?" And it opens up a great conversation piece.
Oh, I see.
Savash is now going, "Now I know what that sign on your door means, David."
Yes.
So,
All right. Interesting. So Hannes has also shared the link in the chat. Also, speaking of sharing links, I'll go ahead and share the previous talk David gave regarding the introduction to the spatial sciences. So the content was the same, but there was some interesting conversation that came up near the end of it with answering some of students' questions. So it might be worth it to take a look at that as well.
skip to the end part where there's the questions. Otherwise, you just hear me talk again, and that's enough to put everybody to sleep.
Your lecture is very enjoyable. I also mentioned another kind of use case for spatial sciences, which is something my wife's actually doing. I talked about when we were talking about sensors. I talked about that how she's tracking motion for white canes and to build a training system, and we talked about the types of sensors she has to use there. We have another one of David's students. I think it's Nimalika is working on it. So the idea is, so if the person who's supposed to be trained is inside a building where you can't use GPS to locate them, so spatial information is going to be useful to kind of pinpoint where they are within the building where you can't use something like GPS. So kind of tying it back to our previous discussion with the sensors and kind of mixing the different parts of IoT, as it were. Everyone happy with their projects, with what they ended up submitting? Any questions, concerns, any comments, possibly about the course?
Isn't it good that everything's gone so well that no one has any questions?
Of course. Should maybe add some sort of a quiz next time you're running the course. Voicing says, "Hi everyone, sorry I can't really participate as I'm in a class. I hope you enjoyed the project."
So you're in a class, but watching owls. That's good. So,
Of course.
okay, thanks, Christopher. 3x3 meter grid. Yep. It gets really fun just on the what three words when you're at someone's house and you pull out the app and you find out what the name of like their lounge room is. So
Interesting.
yeah. I'm trying to remember what was the name of my son had done it for his bedroom, and it was quite funny because it crossed a boundary line of things. So he was very happy. He had 6 words that described his bedroom. So
Interesting. Well, okay, it seems like Anthony has a question. So, Anthony, I'm going to go ahead and unmute you. Yeah, you're unmuted. Go ahead. Sorry, Anton, not Anthony. David, are there any other of your students kind of working on projects with similar spatial sciences ideas, maybe alongside something that can be tied back to IoT?
probably the closest one that ties in, it's not so much IoT, but more on mobile devices, which is location related, is for people using public transport, people who are on the autism spectrum. And using location on their device to know where they are, and then it detects that, and when they become anxious or stressed in that sense, then the app provides them with some information as to how to go about dealing with it and what to do. So not quite IoT, but small devices.
So it's about giving them like spatial awareness of where they are and trying to.
Yeah. So.
And is it about possibly sending information to say, their guardian or their partner to?
Yep. So they can, they have that pre-programmed in, so they can pretty much hit, what we would probably call a panic button, and it will call someone that they've pre-set up. If that person doesn't answer, then it goes to the next person on their list. It can provide them with a virtual communication card, so if they lose their ability to communicate, they can show it to someone on the bus or the train, and it says, "Hi, my name's so-and-so, I have autism spectrum, I'm unable to communicate, can you help me out in this situation?" And it can be quite customized, so things like, "Please don't touch me, just let me follow you," and stuff like that. So yeah.
Interesting.
Yeah.
Well, it seems like Anton signed off. We have about 12 more minutes, so again, please feel free to ask any questions you'll have. I can't think of anything else to kind of stretch more while people get the courage. So if you want it, we can still reach us by that IoT capstone email, and as always, make sure to put in the person who's going to be who you want to read your email. Christopher asked, "Is this the last meeting?" So no, Christopher, we're going to be running another one next week, another seminar, and in that one, I think Valerie is going to talk about databases and probably something about cloud as well. So, and if you can't make it, recorded and posted on the YouTube channel as well. So, okay, so it seems like Anton's back. I'm gonna unmute Anton.
1, 2, 3, 4, 5. Hello, hello.
Yes, coming through. Go ahead, please.
Actually, was 15 minutes late and joined from the phone only, and I missed this starting point. And my questions will be around the projects actually that we are doing and what will be happening next and a half. I understood how it will be.
Sorry, I didn't catch the last part of. What?
My question is around what will be next week and a half. Basically, you will be reviewing our projects and asking for questions, allowing us to do something, and so on.
So Ian and I will go through the project. I don't know if David, Hannes, and the others will have time to kind of read the reports, but we'll read them and we'll give you guys feedback through email. It might just take a little bit for us to actually send the feedbacks through, because there are a number of, I think about 80 reports, an average 20 pages. Once you finish them, you'll see your mark on edX, and your feedback is probably going to come through within a couple of days of that. And next week, as you logged off and came back again, Valerie is going to give a quick talk about databases and cloud a little bit. So we'll have another seminar next week. And if you can't make it, just like the other one, it's going to be recorded, and the recording is going to be posted on the YouTube channel, so you can always catch it there.
And this will be happening next week.
Yes, next
seminar about database. And this will be valid for groups A and B probably.
Yes, that's correct.
So to see that, I anyway will be able to get it from the YouTube.
Yes, so you should also be able to, let me see if I can open the WebEx channel. So you can, let me share my screen.
Probably supposing to join as a
Yes.
group A.
Yes, so next week, so this was Group D, yes, so Group A and B meetings next week, where you can find them on the WebEx meeting tab over here. If you had any trouble with joining the meeting, you can just send us a quick email, and I can email you with the meeting link and the details to joining in if it's in a different group. And again, I'll mention another point that I did at the beginning. Please make sure if you haven't already submitted your reports, email them as soon as possible, because by the time the end date of the course finishes, we really can't put in your marks in the WebEx anymore. So just make sure that end date is fairly restricted, and our hands are very tied if you haven't submitted already.
Oof, but I'm still alive, I think. I mean, the sound from me.
Yes.
That means that I do have enough time to
Yes.
update and send the new version.
Well, we have just a little bit of time. I think it's about 10 more days that we're running the MOOC. But just keep in mind, if you end up like submitting it on the last hour, we won't have enough time to kind of go through it and put your marks in. As soon as
This is logical.
Yeah.
Well, I was actually thinking that if there will be a possibility to get the feedback not only in written form, but like in a Skype call or with Bex, priceless. But of course, I understand that you don't have enough time.
We'll see. Yes, let's go through the marking first, and if I can't find some time between the other units I'm teaching and Ian's teaching and the marking and the end of the semester coming up, we'll set up something online so we can have a quick chat about it. And I'll remind everyone again, Ian posted a link to a Facebook group for people who wanted to kind of keep in touch with their people who did this course, and maybe possibly doing projects together in the future. Keep an eye on that face. I think the link was posted on the discussion board. All right, so we have about 7-ish more minutes. Please still feel free if you have any questions.
If no questions, then still I can bump more questions about the reporting.
Okay.
Average amount of pages that you got is like 10, 20, 15?
I still haven't had a chance to take a look at them, but I would expect these sorts of reports tend to be about 20 pages long. So think about that. And most people have, the ones that I saw have been around 20 pages. There was one that was 96 pages, but the rest of it was appendixes of the sample code. So might give them a pass on that though.
All right. And yet again, if no more questions, then there will be more questions from me. One question is around the progress with prototyping. I understood that technically we defined the plan before and then should demonstrate the result that we progressed with prototyping. And I understood to get a grade in this area, we should pass something like 50% of what is planned. Yes, like if you can comment more about this, because like it's a bit interesting.
Well, I would say keeping in touch through that Facebook group, and we will be kind of monitoring that IoT capstone email. If you're very interested in kind of following up on your idea and maybe getting it to an actual product, I would say that Facebook group is probably the best way to kind of keep in touch with us, that Facebook group and the email address. and especially because there were a couple of people with similar ideas. Might be a good chance to kind of maybe join forces and merge your ideas together to a better one. And again, and Ian has said before, and I'll say it again, we're very impressed with, say, 98% of the reports and the progress that we've seen. I wish our local students were as good, or say as motivated, probably the better word for it. So I think that's going to be a kind of a, hopefully we can turn that to a good community of us and people kind of collaborating.
Then the last question from me, definitely the last one.
No problem.
I'm still doing things with prototyping, and basically I thought that I probably will be able to update my report and send a newer version, which will include, which I got so far.
Well, with that, I'll say it would be probably a better idea to send Ian an email and ask him whether we would be able to consider like an updated version of your report. I know that a couple of people have already I think 2 people have sent like an updated version. But again, please keep in mind, the closer it gets to that finish date, the harder it's going to be for us to kind of go back and mark the reports.
Thanks a lot.
No worries. So, if there are no other questions, thanks everyone. Thanks David. Thanks Hannes. And this meeting, as I said at the beginning, was recorded as well. So you can always, if there was a particular point we wanted to go back and check during David's talk, you can always go through that, and feel free to send us your questions through emails.
Hi guys.
All right.
See you later. Bye.
See you. Have a good night, David.
Yeah, have a good night or a good day, depending on where you are in the world.
Yes, of course.
See you later.
See you.
Thank you, guys. Bye.
Thanks. Bye.